I think you guys can see my screen now and listen to my voice. If you please confirm, we can start the class. Jai, Gopal, Rishabh, Vishali.
Yeah, yes, I can see you.
All right. We are really sorry for the technical mishap because the organizer logged in from his system and all of a sudden he lost the internet connection and he was not able to log out and I'm not able to log in. Finally, it came to one conclusion that I was able to log in now. All right, good. So there was a small request from yesterday's class. Rishabh wants us to quickly go through this platform transformations case and merge that we have seen yesterday. And once we are done with that, we'll go with the remaining transformations. Okay. So a quick recap on case and merge transformation. A case transformation. This transformation is used to split the data into multiple data sets based on a business condition. So if you look at the graphical representation, a single data set. Okay, let me open the job. So if you look at the job, you can clearly understand that a single data set is split into multiple data sets based on a business condition that we provided within the case transformation. So it is very simple transformation. There is no need for us to worry about it or get confused. It is very simple. All you need to drag in is your source table, then drag in the case transformation and connect it with all the remaining output tables. Go to the case transformation. Here we have only one tab, that is case tab, and we have only one schema, that is just a normal schema. And here we were creating these things, like you can create an expression or delete an expression. We are creating an expression here, add expression, and giving label to this expression and go to the column. So once it gives an error saying that there is a name conflict. Okay, so you go to the column, select the ship via column, drag and drop it and put it in the case block and give a condition saying that is equal to 3. Okay, and once we are done, just go back and add one more table and call it as dummy target data store and connect it, and you get Vias 3, the case that we have just created. So this is how we create the case transformation, and this case transformation splits a single data set into multiple data sets based on the business condition that you are giving here. Okay, so to delete an expression, right click on that and delete an expression, and once you delete an expression, you go to the table and delete the table as well. Okay, so this is how the case transformation works, and once we execute this case transformation, it splits a single data set. Okay, so this is of 830 records. It splits that into multiple data sets. So based on the condition, so this is ship via 1, so you have only one values here, ship via, and there are like 249 records on that. And for via 2, there are 326 records. This is ship via 2. And for the via 3, we have another 255 records, and if you check the data, it will have only via 3. So this is the case transformation. And one more thing is the source data set, the metadata of the source table. So the number of fields, the data types, and their lengths will remain same on the target tables as well. Okay, so this is the case transformation, and merge is completely opposite to that. If you just transpose this image, multiple tables are merged into a single data set. So if you look at the graphical representation of merge, okay, so you'll have all these tables on the left hand side and a single table on the right hand side. So this is exactly opposite to the case transformation. You merge different tables of the same metadata type to a single table, and you call that as a merge transformation. Okay, so now let us go to the merge data flow and have a look at it. So we are taking all the output tables of the previous case transformation job. So we took all these tables via 1, via 2, via 3, and the metadata of all these 3 tables are same. So they have the same structure, same number of columns, same data type, and everything remains same within these 3 tables other than the table names. And now I'm using a merge transformation. I just drag the merge transformation here to the designer window. And there is nothing that you need to do. Merge the transformation automatically merges all the tables into a single table, and it generates an output. And once you see this, again you have 830 records, and you have all the regions of shift wire data 3, 2, 1. All these 3 are clubbed into a single data set, and this is how the merge transformation works. So Rishabh, are you clear with this? Yeah, Rishabh, go ahead. There's one question from Rishabh. Click and drop or do anything from merge as we do in case. Exactly, Rishabh. We are not doing anything within the merge, because the moment we drag and drop merge transformation and connect it with the source tables, if the source tables has the same metadata, it automatically merges all these different data sets into a single data set. So it will take care of the entire show. There is nothing that we need to do. Query is, no, it is not similar to query, because we'll look at query and different things that we'll do within a query transformation very soon. So then I think your doubts will be clarified. This is merging. So you have 4 glasses of water and you merge them into a tumbler. So, and everything gets mixed. So how does the data will be ordered? I did not get your question, Jay. So how the data will be ordered in the target? So you mean to say like ascending or descending order, or what? Sorting, if you want sorted information on the table, you can add a query transformation and you can do that, because that's what I am telling you. So once we go ahead, we can do a lot of things within the query transformation. So this is just, remember, this is just merging different data sets. For example, if you have an employee table, okay, and based on department, you split the employees to give the promotions, okay. So for sports department, you split that data based on the case statement where department is equal to sports, and computer science department, you take that department is equal to computer science, and teaching department is equal to teaching. So you take these data from a single table into different data sets, apply different promotion codes on that. One second. Prakash. And then log in a class start just now. Yes, sir. Vachindi. Right. So what we will be doing is we will just split a single data into multiple data sets using a case transformation, and you merge all those multiple data sets back into a single data set using a merge transformation. So this is how it happens. So there is no difference, or if you want to do a sorting on the data, you can add an extra query transformation to that and do sorting on top of that. And this is a little different to the query transformation. Query transformation is something like we do one-on-one mapping, or we select whatever the fields that we require and all these things. So next we will see the query transformation. So is that clear, Jay and Rishabh? Okay, right. So what we will do is we will look at the query transformation to rule out the confusions now. So next one is the query transformation, and query transformation is one of the most important transformation in data services. So using query transformation, you can do wonders. Okay, so I'm not just exaggerating. You can do wonders using query transformation, and yeah. So I'm using a query transformation job. So job underscore query. So I'm creating a data flow. df underscore query. So open the data flow. Now you select some tables from the source. So select the orders table and make it as source. Then you have a query transformation on the quick tool palette on the right hand side. You can click on this and click back on the window, or you can go to the transformations tab, select the query transformation, drag and drop it into this one. Okay, you can do either ways. You can go to the tool palette on the right hand side, click on the query transformation and click back on the window, or you can drag and drop the query transformation from the platform transformation list. Connect it with your source table and you get different options here. Okay, without connecting you cannot open a query transformation. So if you look at this query transformation, it is divided in three major regions. One is your schema in. Okay, this is your schema in, and the second one is your schema out, and the third one is your mapping region. Okay, so schema in gives you the list of columns that are coming from your source table, and just in case if your source table has 100 columns or 200 columns or more than columns that you can count here, so and you want to search for a particular column, you can find by giving the name here. So this find option is there and it automatically takes you to that particular column. So if you click on find next, it will not take because there is only one column called shipwire. So this find option is there. This is one thing that you need to remember. And the second thing is you can either select the fields that you want from schema in to schema out, so that you can exclude all the columns. If you don't want all the 100 columns that are coming from your source, you can exclude them. You can drag whatever the fields that you want, or you can do is select all the columns, drag and drop them to the schema out. Okay, so now you realize you don't want these two columns. Okay, so you can select these two columns, right click and go for a delete. Okay, and you realize that as per the mapping, this is not shipping region, this is shipping regio. Double click on this, change the naming convention, change the data types, change their lengths. Okay, these are the different things that you can do using the schema out. So one thing, when we are creating a flat file, we have seen generate a flat file, create a flat file from here by clicking on the query transformation, right click and go for create file format, which will help us to create a file format. Apart from that, now I want to add this one on top of ship regio. So drag and drop this column. Okay, select this column, drag and drop it on the ship regio, and you get to see all these different options. Remap column means map this column with this column's values, or map this column with this column's data type as well. Insert above, insert below, or cancel. I want to insert that below this. Okay, now I want this postal code to be inserted above this one, so I select insert above. So these things you can do, especially when you are dragging the columns from schema into the schema out. Okay, is this clear? Just dragging and dropping, is this clear? How to insert above, how to insert below, how to delete, how to rename, how to change the data types. Okay, so let us take an example now. When we are doing the merge transformation, I raised a question saying that a merge transformation merges all the similar data sets into one data set. So it can only merge the same table structures. What we will do if we have a different table structure, for example, we have the material information present in an SAP system as well as in an Oracle system. So when you are trying to merge those two, remember, we are not trying to join here, we are trying to merge those two. So if you have a different data set, like the metadata of the Oracle table is different from the metadata of your SAP table, then how you are going to merge them? So add a query transformation between the merge transformation and the source table, and drag the columns, whatever the columns that are present in table A, drag the same columns from table B, and try to rename them in the schema out, and also rechange their data types so that both the source table A and the table B has the same metadata. So this is how you can change them and again merge them into a single data set. So that we can do using the query transformation. And few more things are there you can find as well. You can copy, you can delete, cut. I'm cutting that one and I want to paste that something else. I'm pasting it here. You can do all these cut, copy, paste and all these things. Or you can delete, you can select the employee ID, drag and drop it, insert below the customer ID. So you can do all these things using the query transformation. There are a few more which we'll be looking at eventually, like new output column, new function call, and this is a primary key indicated on a column with a key symbol. So you want to uncheck that primary key, uncheck this one, and this one loses the character of a primary key. So this becomes a normal one, and it can accept a null value and as well as it can accept a duplicate value in this. And if you want to make a primary key column as a primary key, you can make it as this one, primary key. So the next one is the optional. You can tell that this particular column is an optional column. It is not mandatory to have data in that. Okay, you can uncheck that one. And you have the properties which will take you back to this window. So it will tell you whether it is a primary key or not, the attributes for this and the classes for this. So these are the different things that you see in the schema out. The second region and the third region is the most important region. So we have a question coming up. Alright, so primary key is something like, if you make a column as a primary key in a table, so this will be the primary field of that particular table, and this primary key will not allow null values or will not allow any duplicates onto the data. Okay, that is the nature of the primary key. Primary key itself tells that this is a primary key, and in this table on this column you are not supposed to enter any duplicate values, or you are not supposed to enter any null values into that particular column. So if you are good at database, I'll give you a statement saying that create table, a table name like orders, the first column, order ID integer not null, comma, then the customer ID varchar 5, comma, then employee ID. So when I'm making this order ID integer not null, I'm making it as a primary key and I'm not allowing any null values to be a part of that particular column. So is this clear, Bishop? Okay. So this primary key is will also play a major role when you are trying to join this table with another table. So you might have heard about the relationship like primary key and foreign key relationship. So this primary key of this table will be joined with the foreign key of the another table. Okay, that also we'll see now. Now when you go back to the third segment of a query transformation, you see a set of 9 transformations, 9 tabs here. Mapping, select from, outer, where, group, order, advanced, and find. We'll look at them detail now. Mapping. So what does a mapping hold? So if I'm doing a mapping here from schema in to the schema out, so that values will be present here. Okay. So if I map the order ID with the customer ID, so now I'll have a customer ID. So each and every column here will have a mapping tab at the bottom. Okay. So I did a wrong mapping here. So for order ID, it is mapped with the customer ID. So I want to map it back with the order ID. You can drag and drop it here, or you can delete this entire thing, select the order ID, and drag and drop it here in the mapping tab. So this is advantage 1 of the mapping. And if you want to unmap this one, instead of deleting, you can just comment that one. Put a hash symbol, it will be commented. Because sometimes when you are working on the change request, especially in the projects, when you are working on the change request, okay, that is a change request which the client is not sure that it will work or not. So what he will do is like, can you try out this? He will say, can you try out this? And in that time, if you delete the code that you have already created and you are trying to create a new thing for him, that is meaningless. You can comment the code and say that you can write a decode statement, decode if the order ID is null, then replace that with A, B, C, D. So it is an integer, so it will throw an error. So 1, 2, 3, 4. And if it is not null, then get the order ID directly from the source. Okay. So I can write some decode statements here. And once I write a statement, you can see a double arrow on top of that saying that this particular column is getting populated with some functions on that. Or you can do a hard coding thing like 1, 2, 3, 4. I can hard code this one to a particular value. I'm defaulting it to 1, 2, 3, 4. So I take whatever, if you look at once I execute this job, if you look at the target table, all the order IDs will be 1, 2, 3, 4. So I'm defaulting it to 1, 2, 3, 4. This I can do, or I can do a function on top of this, or I can do a direct mapping. And for example, if you are trying to get the data from a flat file, and if you look at the data, space 1, 2, 3, 4 is never equal to 1, 2, 3, 4 because the comparison happens by image to image, and space 1, 2, 3, 4 is not equal to 1, 2, 3, 4. So in that case, you can use the functions like ltrim underscore blanks and rtrim underscore blanks on this particular order ID. So what it will do, it will left trim and rtrim the blanks on this particular order ID. Okay, and close it. So you can utilize any of these functions. You can do you can use the built-in functions. You can write a fixed value for that. You can do a decode, or you can do a direct mapping. So I'm commenting all these things, and I'm letting the direct map stay here. Okay, so this is what we can do using a map transformation. You can either do a direct mapping, or you can write a decode statement. You can fix a standard value or ltrim blanks. Now I have a question. When you have a business rule given by the functional consultant saying that this particular order ID, if it is exceeding this particular range, then it is an invalid order ID. Where are you going to write that? The answer is we are going to write that in the mapping tab. So such functions we'll be writing within the mapping tab of the query transformation. Right? So we covered the major part of the query transformation. Next one is the select. So just in case if your source data is having duplicates, so you can select distinct rows in order to avoid the duplicate. So what it will do is it will take the data row by row from the source to the target table, and if it finds a duplicate coming in from the source table, it deletes the existing record from the target table and it will add the record from the source table. So this is how the logic behind this tool works. So when it finds a duplicate record on the target table, it deletes that and it adds the new record. So select distinct, what it will do is if the same order ID, customer ID, employee ID, and the same record is present 4 or 5 times in your source table, it eliminates those records from getting populated into the target table and it will select the distinct rows. Okay. So next one is the from tab. From tab will tell you from which table the data is getting populated. So now you see only one table here, orders. So you from tab will show the orders here. So now I make it as source, order details, and also connect it with the query transformation. Now if you go to the from tab, you have to see 2 tables, orders and order details. So this will tell you, this from tab will tell you from which segment this particular data is getting populated and what are the different tables that are used as a source transformations or the schema in for this particular query transformation. Alright. So this from gives you the list of tables. Now we'll do some small modification. So I don't want all these columns here. So I want the product ID, unit price, quantity. Right. When I'm trying to join 2 tables and create a structure, a new structure, few fields from table A and few fields from table B, I need to propose a join between these two tables. So that you can do in an outer join or in the where condition. If you are trying to do an outer join, then you can do it here, or if it is a normal inner join, you can do it in the where condition. So where condition, say the order IDs, it's very simple. The order IDs of the orders table is equal to the order ID of the order detail tables. I'm just selecting those fields, dragging and dropping them into the where condition, saying that this is what I am trying to do, or this is the condition on which I am trying to join these two tables. The order ID of the orders table, so you can look at this one, the order ID of the orders table is equal to the order ID of the order detail tables. So this is a simple inner join, and if you want to make an outer join, okay, right click here, go for insert. So I repeat, so there is no option available here in the outer join. So if you see it, there is no option available. All you can do is like right click, go for insert, and here you can choose what is your inner source and what is your outer source. So what it will do when you are doing an outer join, it will get all the fields of the outer source table and the mapped fields from the inner source table. And in just in case if you don't find a mapped field for a particular row in the outer source table, that particular columns from that are getting populated from the inner source table will be populated with a null value. So that is an inner join and an outer join. So these are the very fundamental things of data warehousing. So inner join is like just you join two tables and you get the common data out of them. It is something like an intersection where the order ID, yeah, it is like an intersection where you try to get the data from two different tables, the common data, by proposing a where condition saying that where the order ID of table A is equal to the order ID of table B. So the common records in both the tables will come up, and outer join is something like an union, or yeah, it is not even like an union, it is like table A, all the fields from the table A and the mapped fields from the table B. So if you take these two diagrams, one second. So if you take these two diagrams, table A and table B, so this outer join, what it does is it gets this portion as well, okay, even this portion from the table B, which is a part of table A, and it gives you the join condition, and whenever there is a no matching record found in this particular part, it replaces that with the null value. So that is an outer join that we can do here. If you want to delete this, right click and delete, or if you want to add, right click and insert. The next one is the where condition, where you can give more than one condition saying that where the order ID is equal to order ID, and if you have any primary keys and foreign keys, you can call them here saying that the product ID is equal to, if you have a product ID from this table, you can drag and drop it here, or if you have a customer ID in the order details table, you can do this AND operation, or you can do OR operation. Okay, you can do AND operation and you can do OR operation. So it says that either the first condition or the second condition is valid, or either the first condition and the second condition is valid. So you can propose a join between the tables, and also you can use this where condition as a filter. So what I want to say here is these two tables are joined with this condition, and I don't want the shipping regions, which are 1, is not okay. So the shipping wire is not equal to 1. So what it will do, it will eliminate all the shipping vias 1 from the data that is coming as an output. Or you can give this not equal to symbol, or you can give not equal to 1. Okay, so validate, there are no errors. So you can use this where tab of a query transformation both for joining two different tables And also if you are using one table as a source or two tables as a source, you can give a filter condition as well. Okay, so this is and also you don't want some product ID like 1234. If you have a product ID, so you say is not equal to 1234. So you can write as many conditions as possible. So you can write a filter condition, you can write a join condition within your where tab. So don't get confused with the mapping and the where, because where is used to join and filter on the data, but mapping tab, which allows you to write similar conditions, is especially used for doing all these values. You can do a direct mapping, you can write a decode statement, you can write an if then else statement, you can directly map it with a fixed value, or you can utilize the built-in functions on top of these columns. Okay, so this is the difference. So this is the where tab. Next one is a group by tab. For example, let us take an example of a postal address department, postcode department. So what this postcode does is, when it gets all the queries related to that particular address or particular region, it tries to group by them as per the postal code. So or as per the regions. So if a particular city is taken, it is split into 4 regions: north, east, south, west. So first the postal department will try to segregate these envelopes per region, so that it puts all this north into one bundle, all the south into one bundle, or all the east into one bundle, and all the west into another bundle. So it tries to separate the data or bundle the data which is related together. So similarly, group by allows you to do a group by on the data where it is present in which has a common functionality. Because for example, if you take the employee information, and if you want to do a group by on the managers, so you can select the manager column, okay, and or you can select the manager column, drag and drop it on the group by, so that what it will do is it bundles all the employees whose ID is the manager ID together, so that you can search within that very fast. Okay, so a group by, what it will do, it bundles the data into different buckets, or it pushes the data into different buckets, so that you can search quickly within that bucket. And there is one thing that you need to remember when you are working with BODS, when you are trying to do a group by on this query transformation. You should make sure that all the fields that are present in your query transformation schema out should also be present in your group by. So what are the columns that you are trying to drag as an output in the schema out? All of them should be present in the group by tab of the query transformation. If not, it will throw an error. So if you don't want to do group by on all the fields, but for example, you don't want to do a group by on the quantity, and you want to allow all the remaining columns to be grouped by, but you don't want to do a group by on the quantity. So in that case, what you can do is go to the mapping on that particular column, and you can use the map functions like sum of, or minimum of, or maximum of. So you can use these functions like sum, minimum, average, count, maximum. So all these 5 functions you can utilize on top of the remaining columns, so which are not part of your group by. So generally speaking, all the columns that will be in your schema out will be dragged and dropped into your group by, and which are not part of your group by will be placed with the functions, minimum, maximum, math functions. Okay, that is a group by. And the next one is an order by. Order by. So Jay, your question. So you want the data to be sorted. So where we will be doing this? This is the place where we'll be doing that, saying that sort the data as per the ascending order or descending order. Okay, so you can drag any column on which you want to sort the data, and you can sort this data onto the target table by doing an ordering on that. So you can sort it by an ascending order or descending order. So this is order by tab. The next one is the advanced tab. So Why we need this advanced tab here? Because if you look at the different things that we are trying to do within a query transformation, so these different things will take a lot of memory. So first one is run distinct. So what it will do, it has to compare all the records of the source with the target so that the same duplicate is not pushed into the target table. For example, you have 10,000 records in your source and 20,000 records in your target table. 10,000 into 20,000 iterations should happen. So that is one resource consuming thing. So you can run that distinct as a separate process just in case if you have huge volume of data. Then group by as a separate process. Again, this is also a resource consuming activity. What it will do? So how does group by work? It takes the first record of the source table and it compares with all the remaining records of the source table, and whenever it finds a match as per the group by logic that we are giving here, it tries to bundle them into one bucket. So if it finds 10 records in the entire table of 10,000 records, it will bundle them into a single bucket. So similarly the next record. So similarly the third record. So if you have a 10,000 records table as your source, so 10,000 into 9,999 iterations will happen at the max on when you are doing a group by. So all these iterations, where they will happen within your BODS cache memory. So there is no other place that they can happen. They can happen only in your BODS cache memory. And they will literally occupy your system and they will make your system pretty slow. So if you are doing a group by and a huge volume of data, remember you have to check this group by as a separate process. Then join as a separate process. Okay, so when you are trying to do a join using multiple logics, like we are just trying to do a join using only one field, where the order ID of the source table is equal to the order ID of the second source table. But when we are trying to do a join by so many columns, like the order ID is equal to the order ID, employee is equal to employee ID, customer ID is equal to customer ID, and so many fields. So you are trying to join so many, not even just two tables, you are trying to join 5-6 tables using a query transformation. Then probably the first table's first record has to be compared with all the remaining tables, 6 tables records, and then only it will be passed to the target table. So that is again a tedious task for the system, so you can run that as a separate process. And again, order by, it is also, sorting is also an resource consuming, because it compares the first record with all the remaining records and it tries to first identify the least value, put it on the top, then the second least value, put it on the top. So for each and every placements on the top, so it is comparing the entire data set. So that is one more resource consuming thing. So you can improve the performance of all these things using advanced tab of the query transformation by running them as a separate task. Okay, so what it will do in the backend, like it will allot a separate process area for these things to run, so that these will not impact on the general process areas, and it will improve the performance. And last but not the least, we have a find tab here. So find what, if you have a number of columns on your schema in or schema out and you could not find it and you want to search for that. Okay, I give the name order ID and I can choose the schema in which I want to search this for. So just click on find, it gives me on the schema out. Okay, this is the field on which I am trying to find, so you can double click on that and do changes on top of that, and you can allow the system to search in both the schemas as well. Okay, so order ID, this is an input, and second order ID is from this table. So you can see the switch when I'm selecting the first one, this one is coming up. Again, there is another order ID, this is the third order ID that is from the schema out. So you can search in both the schemas, and this is fine if you have, just in case if you have more number of columns, you can do a find on that. And find and replace is one more option. Find the order ID and replace that with ORD ID. Okay, if you want to change the name of a particular marker of a table, so this particular marker is present on all the columns, so you want to change that, so you can just do a find and replace just for the schema output schema, and for You can choose which mapped or unnested functions, all schemas, unmapped columns, simple error columns, and all these things. So I just go for all types. And properties, you can choose in which tab you want to do a change, order by, group by, outer join, from, where, mapping, type, descriptions, and names. I select all properties and replace. Now you see this order ID is replaced with ORD ID. So this is a quick way we can find and replace this thing. So these are the different things that we can do. So this is one of the most important transformation. One is like you can do a one-to-one mapping. Okay, now it throws an error because here this one is mapped with a wrong value. So this is not ORD ID. This is the order ID that is coming from the source. Now this into mark is gone. Okay, so if there is any error in the mapping, it shows the cross mark there, red cross mark. So this is the mapping tab. Select tab is used to select the distinct records. From tab is used to show the list of tables that are coming as from your source. Outer join to define the outer source and inner source. Inner join using the where condition, and group by, order by, find, advanced and find. So advanced will help you to run them as separate process. So now let us create a target table and run this job. I call it as query staging. I save it in the target table and try to execute this job. So when you're practicing on your systems especially, you can it throws an error. So what is the error? Please check the spelling of the column. So there is one error with this. Alright, so invalid where clause. So this is renamed. So just delete this one and select the order ID is equal to the order ID. Go back, validate all. So order by clause. So you can directly right click and go to the error. It will take you to the error. Okay, delete this one. Save it. Validate this one. No errors found. Right click and execute. So now it is trying to join the data from the two tables. Okay, and it is trying to push it into the target table. So job query is successfully completed, and 2155 records are brought as an output to this target table. And now if you look at this, it has 2155 records in your target table. So this is one of the mostly used transformation within the data migration part. So what I suggest you is, like, when you're practicing this on your system, you have to continuously try each and every option of that. Try to understand what is the difference that is happening on the data when I check this option, what is the difference that is happening on the data when I don't check this option. So each and every tab of your query transformation, practice that rigorously, and if you are stuck somewhere, send me an email and I'll respond to you on top of that. But this is an assignment. Do all possible things with using a query transformation to understand how it works. Okay, so it's already late for me. We'll call it a day. So any questions before we call it a day? Do you have any questions? Alright, so quick announcement for Jay. I think your system is working good. I created a notepad or like a Word document on top of your desktop, so you can log into your virtual machine and see that. And I create the username and password using which you can log into your repository. And Gopal, I think the error was rectified, and you can try logging into this one. And for management console, in your case, in your virtual machine, what you need to do is, like, you need to log in with your username and password using which you log into the virtual machine. So they have normalized all those things. So that should work. And if you have any questions, I think, so can you just okay. So I think I sent you a document yesterday. You can refer to that document and create a login in that system if you have any error. Alright, so still I'm not getting the repository tab. And I log in with my user ID. Which repository? When you're going to the repository manager, alright, so we'll do one thing. Send me your credentials, Gopal. Email me them. So today evening I'll log into your system, and once I'm back from office, I'll log into your system and try to rectify that. And I'll leave you a note on your desktop once I'm done with that. But guys, I'm getting late to the office, so if you have any questions, please mail me at bo.dataservices. You're most welcome, Gopal. So thanks for your time, and especially sorry for the first 15 minutes delay that we had due to the technical problem. So tomorrow again we'll catch up at the same time at 7 a.m. IST, and we'll try to continue the class. Okay. All right. See you guys. Thanks for your time.